Section 4.2, Measures of Spread. When we talk about measures of spread, here are the three items that we're looking at: the range, the variance, and the standard deviation. Spread meaning how spread out the data is. Now, when discussing the key elements of a set of data, we need to know three things. One, we need to know the shape, whether it's unimodal, bimodal, multimodal, and skewed left, symmetric, and skewed right. Number two, the center, being the mean, the median, and the mode. And number three is the spread, which contains the range, the variance, and the standard deviation. When we say spread, we mean how spread out or how dispersed the data is. With the three measures of spread that we will learn to calculate in this section, the larger the measure of spread, the more spread out, dispersed the data will be. For example, the two histograms below give the distribution of the IQ of a sample of students from two different universities. Both of these universities have an average IQ of 100. However, from the histograms, you can see that the two distributions are very different. The distribution of IQs for University B is much more spread out than the distribution of IQs for University A. This means that for University A, most of the students have an IQ that is close to the mean, whereas with University B, there are many students who have IQs that are very different from the mean. If we were able to calculate the measures of spread for the two universities, University B would have a larger range, variance, and standard deviation. So here you can see how University B would have a larger range, a larger variance, and a larger standard deviation. Objective 1. Compute the range for a set of data. The range for a set of data is given by R, which is equal to the largest number minus the smallest number. So R, again, the range, is equal to the largest number minus the smallest number. Okay, so let's take a look at the example here. So we want to find the range for the following sets of data. So for the sets of data for part A, we know that the largest number in our data set is 15.6. And then we're going to subtract the smallest number, which is 6.2. So the range is 15.6 minus 6.2, which is equal to 9.4. In part B, we're going to use almost the same data, but you can see here that 13.4 now has been replaced with 90.4. So we want to find the range of this data. So the largest number in this data set is 90.4, and the smallest number is 6.2. So 90.4 minus 6.2 gives us 84.2. So this means that it's more dispersed. So the larger the number in this case for the range is telling us that it is more dispersed than the first set of data. So what is the effect of outliers on the range? So 90.4 would be an outlier. Well, that would state that the range is not resistant. Now another example states here, we want to find the range in sales and explain what it means in this situation. Vehicle sales in April 2014 are shown in Table 20 for each automaker. So for Table 20, we have the vehicle sales in April 2014. So we want to find the range. So the largest sales is represented by General Motors at 254,076. And then we're going to subtract the smallest, which is Subaru at 40,083. So when we subtract those amounts, we get 213,993. So what does it mean in this situation? it means that the range is 213,993 vehicles. This suggests that the spread of the vehicle sales of the automakers is quite large.